And we're live again. Okay, so this is the last one I'm going to do for right now, and then I'll come back and do the last piece later. What we're looking at now is logarithms. And so essentially what I want to do is just kind of go through some general pieces and then go through some problems. You got this pretty well down, but we'll kind of hit it again. What you need to know about a log is that it is the inverse of an exponential. And so essentially it's just a different way of writing it. Now it works in a little bit of a different way, but we'll deal with that in a second. So when I'm talking about this, what we had talked about before is if I have a base to the x power is equal to some answer a, and that's our exponential, then what I can do to write that in log form is just reorganize it. And that is then I have the log of the base, log base of the answer is equal to our exponent. So this is logarithmic form. Now, really, most of the first part of these problems with 16 and 17 is sort of going back and forth between the formats. So you're not being asked to solve anything yet, but they're just asking you to sort of rewrite these problems. And that's not that big of a deal. So if I have something like this, like if I take problem number 16a, it's pretty easy, and I'm going to just do kind of two of these to make sure that you know. So if I've got x to the 3 power is equal to 5, and I'm going to write that in logarithmic form. So I've got log. The base is what goes down here, so that's going to be x. The answer, which is our 5, goes there. And the exponent, that is equal to 3. There's our deal. Going the other direction, if I start with a log, let's go 17b. If I've got log base x of 8 is equal to y, which is where I'm starting, then to go back in the other direction, all I have to do is say, I know that this is my base, my x, so there. This is my answer, so there. And this is my exponent, so that means it goes up here. So x to the y is equal to 8. Again, you did a really good job with these. I just figured showing one of each is probably not a bad idea. Now, when we start talking about expanding and contracting logarithms, we have, which is what we have a little bit later there, we have exactly 3 rules to remember. One of them is what we're going to call our multiplication. So if I have the log of 2 things being multiplied, and again, the base stays the same. I could write it as a base, but let's just keep it as a log, so we're assuming it's like having log base 10. Of 2 things being multiplied, a times b. Then that is the same thing if I wanted to expand that of saying log of a plus the log of b. The way that I remember this is that when I am using exponents, which is kind of what logarithms are about, when the bases are the same and they're being multiplied, we add their exponents. That's kind of a way of remembering this part of it. And in the opposite direction, if I'm dividing them, we subtract exponents. So log of a divided by b is the same as log of a minus log of b. The final rule, and it's one that you use a lot more later, but it's something that's sort of important, is one that involves exponents. So that if I have taken the log of something raised to a power, so like a to the x, that is the same as taking that exponent and bringing it down to the front as a coefficient. So that's the same of saying x times log of a. The reason you need these is because when you have problems like 18, 19, and 20, and they're asking you to put logarithms together or take logarithms apart, what they're really asking for you to do is to figure out where to put everything so that it works nicely and neatly. So when I start with a problem like 18a, which I will do off to the side here, we've got a little bit of work to do. It gives us log of 4 to the 3rd power plus 2 log of 5. And they're asking for us to put this into a single logarithm. Fortunately, we have an exponent up here already, so we don't have to bring it up. But in order for us to combine, if you notice our rule here, I can't have anything in front of either logs if I'm going to combine them to make them one thing. That's the case with both subtraction and with addition. So that means that I have to take this coefficient 2, and I need to bring that up as an exponent. So I will rewrite this as log of 4 to the 3rd power plus log of 5 to the 2nd power. I just brought it up as an exponent. Now that I have that, what I can do then is to combine these two things as a single log, which is what they're asking for. Addition combines the two terms as multiplication from our rule here. So I can then say log of 4 to the third times 5 to the second, and I've combined it as one log. Now, it is possible that you would be asked to find the solution. 4 to the third is 64, 5 to the second is 25. You can multiply the two of those and you can get your answer, but I don't care what that is right now. Going the other direction, like you do with 19, if I start off with 19a, and I've got log of 2 to the fifth times 4 to the third, holy moly, look at what we have here. It's exactly the same thing that we did before, but it's asking for you to expand each logarithm completely. It's kind of interesting. I didn't even know that they had done that, but hey, what are you going to do? In the case of doing this, let's go through the steps and pretend like we didn't see the one before. If I'm expanding, well, the first thing that I have to do is look and see if they have either they're both being raised to an exponent or they're raised to separate exponents. Since they're separate, I can't just bring them down as one thing. So I have to split these up into two separate logs and then bring down my exponents. So when I see multiplication here, it tells me I need to split it up using addition because I have the rule there. So I'm going to write this as log of 2 to the fifth plus log of 4 to the third. By the way, I just recognized 2 to the fifth and 5 to the second, not the same thing. So this isn't exactly the same problem, but dang it, it's really close. Okay, now if I'm going to expand them completely, I can no longer have exponents up here. I have to bring those down as coefficients. So that means this goes down to the front, and I will have 5 log of 2 plus this coming down to the front, so I will have 3 log of 4. And that gives me enough information to say I've expanded it as far as I possibly can, and I'm done with that. Now we're gonna move on to problem 20, which uses the same general idea, but has us look for patterns with the numbers we have here. So right now they tell you that log of 2 is equal to 0.301. They tell you that log of 3 is equal to 0.477, and they tell you that log of 5 is equal to 0.699. Now, this is completely and totally an exercise of your brain. It is not something you would need because your calculator, in fact, has these values, but this is the way that people used to have to do everything. So, just bear that in mind. I'm going to do B for problem 20 because I think it'll help out to see what we're talking about. We have log of 9 over 2. The key to all of these problems is how do I take this term and write it in terms of 2, 3, and 5. I should say and or 5. We already have a 2 down here, so that takes care of our first one. We know we've got to deal with that. Can I write a 9 in terms of a 3 as a base? And by golly, I can. I'm going to rewrite this as log of 3 squared over 2. Now that I have that, everything's in terms of 2's and 3's and or 5's. We don't need any 5's. And so now I'm just going to split them apart. In the case of this, I see it's a division, so I can say that this is the log of 3 squared minus the log of 2. And to continue to expand this, I want them to bring this down to the front. I can say 2 log 3 minus log 2. What they're going to ask you to do to evaluate it then, once you have these set where it's just a log 3 and just a log 2, is to substitute the values that they gave you in the problem. So this will be 2 times 0.477 from the value they gave you at the beginning of the problem, minus 0.301 that they gave you from this part of the problem. Now, I know that you can use a calculator to evaluate this part. It was setting it up that's the most important, and I'm not going to do the multiplication. What I am going to do now, though, is to get each of these different things for 21 and start talking about how to use logs to solve equations. And I think in the case of this, doing A and maybe C would be good problems to sort of think about a little bit. In the case of A, we've got log base 9 of 243 is equal to x, and I'm going to solve for this. Now, I'm going to tell you the easiest thing for me to do here is to recognize that I don't have a log base 9 in my calculator, but I do have a log base 10. So what I need to do right now is to put this into some format that will allow me to work with it, okay? And so this is what I'm going to do. The way that I handle these first, I'm going to first write this as an exponential because I'm not a big fan of the way this is written. There's another way, but I don't like it, so this is going to be the best way. If I write it as an exponential, I will have 9 to the x power is equal to 243. Now you can plug this into any calculator anywhere, and you will not find an x value that will work. This is where we're using a different function of logarithm. Because the log base 10 is something that's like a button on the calculator, I can simply use it to take something of both sides. So what I'm going to do is introduce log in a bit of a different way. I'm not just rewriting an exponential. I am taking a new base log, which is the calculator on the button, of both sides of the equation. So because I've done it to both sides, I can still keep the equation balanced. I don't have to do anything different with it. It's just something new that I can do. Now, I'm trying to solve for x, so that means I have to get the x in a place that it can be used and solved for. Because it's up as an exponent, because I have taken the logs, the rules tell me now I can bring it all the way down to the front as a multiplication piece as opposed to an exponent. So this will be x times the log of 9 is equal to the log of 243. And in the case of this, since I'm trying to solve for x, I can divide both sides by the log of 9, and I will solve for it. Log of 243 divided by the log of 9 is going to give me my answer. Now, we call this calculator-ready form. I can plug this into the calculator, get log of 243, which is going to be some crazy decimal, divided by log of 9, which is going to be some other crazy decimal, and it will give me what the x value is. Almost every problem that you have a number to an x is equal to another number, this is the method you use by taking the log of both sides, bringing your x down and solving. But this is the way that this one ended up working out. If you need to rewind this and look at it again to see how that worked, please do, but really that is the way of doing it to make something like this work. Now, for the last problem I'm going to go through, I'm going to do problem C, which involves some of the same issues that we have here. 375 is equal to 3 times 5 raised to the x plus 3 power. Okay, they're kind of trying to trick you here by putting that 3 out there on the ledge. Get it over to the other side. We don't want it there. And so when I look at something like this, I'm going to divide both sides by 3. Now, I believe this actually divides evenly, and it's going to give you 125 is equal to 5 to the x plus 3 power. Now, there's a lot of stuff that we could do here. I am going to show you a way that will work regardless. And then I'm going to show you a way that you can do this using different bases. So right now, we'll do two methods. One is going to be the log method, and one is going to be the base method. I think they're probably trying to set this problem up so you can use the base method, but I like using logs, so that's what we're going to do. Just like we did before, when we have a number to a power with an x, and we have another equal to another number, I can take the log of both sides. The process at this point is almost exactly the same. Let's see if I can get this sucker to focus. That looks a little bit better. Okay, I'll make this a little bigger as we do it. I'm going to bring this exponent down to the front again. So we will have log of 125 is equal to x plus 3 times the log of 5. Again, the process remains almost the same. I'm solving for x. I'm going to bring this log over to the other side. So we will have log of 125 divided by the log of 5 is equal to x plus 3. And the next thing that I'm going to do to solve for this is to say, if it's x plus 3 and I'm solving for x, I could just subtract that to the other side. Log of 125 over log of 5 minus 3 is equal to x. Again, this is something that I can just plug into my calculator, get this answer, subtract 3. I will tell you right now that the value that you're looking at here will be a whole number value. And when you get a whole number value, your answer is going to be something else. This is a way that it looks more complicated than it really is, but it should work out. The other thing that I'm going to tell you is this. We have a division here. And I remember when we were doing those things before with the laws of logarithms, I'm about to bring that sheet back, we saw that division would turn into subtraction. But let's look at the way that this is written. This is a single log of two things being divided that allowed us to split it. The difference here is that I have two separate logs. There's no separating this or combining it as to log of 125 minus. None of that works. This is just something to plug into the calculator. So I don't want you to get confused on that. And if what I just said was confusing, then skip over it because it's a video and you don't have to listen to anything that I say. Okay, the base form that's different only works when we have two things in our problem where they can be written as two bases with the same exponent. In the case of this, 125 can be written as 5 raised to the third power. Because I can write that, I can rewrite this problem as 5 to the third equals 5 to the x plus 3. Again, this only works when the bases are the same. Because I have it this way and the bases are the same, what you can now do is say, since these are this way, I can set the exponents equal to each other, and I can say that 3 is equal to x plus 3, or ultimately that x is equal to 0. And that's absolutely true. What I would say you will probably get when you plug this into your calculator, I believe you will get 3, so you get your final answer that x is equal to 0. Both ways work and it should be fine, and that is the end of logarithm work that you have on this sheet.